Chapter 11, Question 11. College athletes, especially males, are often perceived as having very little interest in the academic side of their college experience. One common problem is class attendance. To address the problem of class attendance, a group of researchers developed and demonstrated a relatively simple but effective intervention. Picard, Lott, Mills, Picard, and Baylock-Casey in 2012. The researchers asked each athlete to text his academic counselor in class as soon as he arrived at the classroom. The researchers found significantly better attendance after the students began texting. In a similar study, a researcher monitored class attendance for a sample of n equals 16 male athletes during the first 3 weeks of the semester and recorded the number of minutes that each student was late to class. The athletes were then asked to begin texting their arrival at the classroom, and the researcher continued to monitor attendance for another 3 weeks. For each athlete, the average lateness for the first 3 weeks and for the second 3 weeks were calculated, and the different score was recorded. The data showed that lateness to class decreased by an average of MD equals 21 minutes, with a sum of squares of 2,940 when the students were texting. Use a two-tailed test with an alpha of 0.01 to determine whether texting produced a significant change in attendance. So the first thing that we need to do is that we need to figure out our hypotheses. So step 1 of that hypothesis testing procedure, we need to find our null and our alternate. So we've got a two-tailed test. Our null is that there is no difference. Our alternate is that there is a difference. It's not specifying whether it's going to increase or decrease. Step 2 of the hypothesis testing procedure is to find our critical values. In order to do that, we need to calculate our degrees of freedom. Degrees of freedom is n minus 1. N was 16, so 16 minus 1, so it's 15. We use that and the t-test table in the back of our book, and we find that our critical value, our critical t, is plus or minus 2.947. Step 3, we calculate the statistic, the t-test for two related samples. Before we can do that, we have to calculate our variance because we have been given sum of squares. So our variance is equal to the sum of squares divided by n minus 1, divided by the degrees of freedom. So what we're going to do, we take 2,940 and we divide it by 15, and what we get is 196. Before we can calculate our t, we're going to have to calculate the estimated standard error, which is the square root of the variance divided by the sample size. So we take the variance, which was 196, we divide by 16, and we take the square root. That is equal to the square root of 12.25, which is 3.5. Now we can plug this value into our t formula. So t is equal to the mean difference minus the predicted value, which we get from our hypotheses, divided by the estimated standard error. The mean difference was 21. Minus 0 divided by 3.5. That is equal to 6. Step 4 is that we need to compare the value that we calculated to the value that is our critical value. Our critical values, we have a two-tailed test, 2.947, negative 2.947, and our value that we calculated is out here, So this is our region of rejection, So our decision is we're going to reject the null and accept the alternate. This is my cat right here. He needs to be here, but at least he's not blocking anything. And to interpret that, so we've got the evidence right here. The value we calculated is more extreme than the critical value. And to interpret it, if you reject the null, that means there is a significant effect. Texting reduced tardiness significantly.